Hi everybody, welcome back to the Pythagoras channel, and today I will be making a video on graphing polynomials, concluding the three-part series on polynomials. So here I have given us 3 problems, and we are going to show an example of a sketch of these graphs, because without calculus we cannot do more accurate graphs, but we're going to be working within the confines of algebra. So let's begin. Alright, so here we have question 1. X times x minus 1 times x plus 3. And it wants us to find the degree, zeros, y-intercept, range, and the graph, and sketch the graph of the polynomial. And now, you might be wondering, why only range? Why not domain? This is a polynomial, which means it is defined for every single number. But sometimes, if a polynomial has an even degree, then it might not have a range for all numbers. So, let's begin with this. So, first, we have x times x minus 1 times x plus 3. That degree, we can just see by, if we were to multiply it out, we can tell that the leading term would be x cubed, because we'd have to multiply this x by this x as well. So that means we have the third degree. And what that tells us is, since we can basically imagine a positive one out here, that means it's positive, which means the end behavior of the graph is going to be, it's going to go from negative to positive, minus to plus. Alright? And then we have the zeros. And when you have a polynomial written in factored form, to find the zeros, you just find when each of these terms are equal to 0. X is equal to 0 when it's 0, so we have 0. And then x minus 1 equals 0, x equals 1, 1, and x plus 3 equals 0, x equals negative 3. Now we have the y-intercept, and this one is a little different. If we were to have the polynomial written in expanded form, where we multiply out all these terms, then we could have our y-intercept. However, something we can notice is all these terms are going to have an x. They're all going to end in x. There's no constant term, which means our y-intercept is also the x-intercept. It's 0. So our y-intercept is actually 0, 0. But if we didn't have this x out here, then it would just be these two terms multiplied, 2 constants. And now, what we do is for our range. Now, if your degree is odd, the range is going to be all real numbers. So what we can write in interval notation, negative infinity to infinity. Oh, not brackets, parentheses. Oh, it's always parentheses with infinity. And now we have to sketch the graph. So the first thing I like to do is you'd also determine the multiplicity of the roots, because we see here none of them are more than to the first power. You can think x to the first, x minus 1 to the first, x plus 3 to the first. So, if you wanted to find, let's start with plotting the points where the zeros are. And here, we'll just call that 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That means x minus 1, or where x equals 1, we can draw a point there. And then x equals 0, and then x equals negative 3. 1, 2, 3. And now, what we want to do, we know that this function is going to go, it has to start negative, so it's coming up from here. I can draw it like that. And then, it's going to go up, and then it has to come back down to hit 0. So, you can draw it like that. But now we know this has to also come back up, because it's going to go through this point, x equals 1. So, what that means is our sketch is going to look something like this. And a good way to double check your work is to notice that you have 1 point, 2 points. There are 2 turning points. And we're going to have, as the degree, the degree is 1 higher than the amount of turns here, unless if there's a double root. So, now that we have this one, let's go on to the next problem. Now for question 2, we are going to look at this polynomial. negative x squared times x squared plus 4x plus 4. And what this one is telling us is we have a negative coefficient out front, which we may keep in mind. But first, we want to write this in fully fractional form. And this is going to be equal to negative x squared times x plus 2 squared. And quickly double checking, x squared plus 2x plus 4. And yep, that's what we got. Now we're going to look at the degree. The degree is just going to be this times this, and the power of x is x squared. X squared 2 plus 2 is 4, so our degree is 4. Next, we have to look at the end behavior, and since this is to the 4th power, and it's an even power, and there's a negative out front, that means it's going to be going from negative, and it's going to end up at negative. That's the end behavior. And now we have to find the zeros. And what the zeros are just these two factors. But this time, we have to consider the multiplicity of those zeros. So, writing that, we have 0, and to denote multiplicity, I'll just write m2. And the multiplicity is simply the power that it's raised to. So, we have 0, m2, and then we also have negative 2. We have negative 2, m2. Alright, and now we have to find the y-intercept. And something to note, when your x-intercept is 0, your y-intercept is 0. And that just means this is going to be 0, 0. You can also see all the terms are going to end in x, and that means we set x equal to 0, y is also going to be equal to 0. So, now what we want to do is we want to start graphing this. So, let's go. 1, 2, 3, 4. 1, 2, 3, 4, and our y scale doesn't matter here because we're not using calculus. And now what we want to look at is y-intercept 0, 0, and we want to plot again our other zeros. We have 0, multiplicity of 2, and negative 2, 1, 2, and now we know it's going to be negative, so that means we're going to start it off down here. We're going to draw an arrow, and now this is a double root, right? Negative 2, it has a multiplicity of 2. That means it's not going to cross through this, rather it's going to bounce off this. And now, for us to get over here, to get to 0, we're going to have to start increasing again, which is where we do that. Now, and just know these y values are all guesses. And now we're going to have to, again, multiplicity 2, we're going to bounce off this 0 again. And we're going to go down. And that is our sketch of the graph where there's a little bump in the middle. And now, this is how this one works. It's going to negative infinity on both sides. And actually, what we can see is our range. You can see that it never crosses above the x-axis. So that means our range, we just go from negative infinity to 0. So infinity 0, and the 0 is in brackets because it is included. Now we are going to take a look at our third function. Lastly, here we have 2x plus 1 cubed times x squared minus 5x plus 4 times x plus 3. And now, first, evaluating the degree. There's going to be x cubed here, times an x to the squared, times an x, that's 3 plus 2 plus 1, which is going to become 6. So our degree is 6. There's no negative coefficient out front. So what that means is we're going to be going from, since it's even, it's going to be from positive to positive. Now we have our zeros. And what we want to do is we want to rewrite this expression. So let's get this. And we can keep the 2x plus 1 cubed. But we also want to factor that middle term. And we can factor that into x minus 4 times x minus 1 times x plus 3. And this x plus 3 is the same one over there, and this is what that middle quadratic factored into. Now, what we want to do is, what exactly is the 0? And we can just quickly 2x plus 1 equals 0, 2x equals negative 1, x equals negative 1/2. And that's going to be one of your zeros. And now, of course, we have to consider the multiplicity of it, right? Because it's not just 1, it's 3. There's 3. So that means it has a multiplicity of 3. So for zeros, we write negative 1/2, and then in parentheses and 3. And I will show you what that looks like in a graph shortly. Now we have negative 1/2, and our few other zeros is when x equals 4, x equals 1, and x equals negative 3. So 4, 1, and negative 3. And now we have something interesting with our y-intercept here. So what we want to do is we could multiply this all out and then find our constant term. But why don't we do something a little smarter and we just only multiply out the constant terms? Because each of these numbers are going to have to multiply each other eventually, right? So what that means is, let's look at this thing cubed here. So 1 cubed is going to be 1. It's the only constant in here. That's the only constant term, so it's going to be 1. And then we're going to multiply that by minus 4. So that's going to be negative 4. And then we're going to multiply it again by minus 1. And then, so that goes from negative 4 to 4. Then we're going to multiply that one last time by 3. And that makes our intercept 12. And of course, we know the value of that is going to be 0, 12. And if you want, you can just plug in 0 then. This is going to be 1 cubed times negative 4 times negative 1 times 3. This, 4, 3. All of that. So it makes sense. And now, to draw our graph. Now, we know that we have y-intercept at 12. So let's make one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's where our intercept will be. And now we have a 0 at negative 1/2. And I'll make our x scale pretty large. This is going to be 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Now, negative 1/2 is going to be right about here, and 4 is going to be right around here, and negative 3 is going to be right around here. And don't forget 1. 1 is going to be right around there. Now, what we're going to do is, let's start this from the far left. The lowest 0 is negative 3, and we know it's going to come from a positive direction, so this should be shooting off like that. Now, we have to work and connect it to here, and negative 3 is a regular root, so it does just pass right through it. But now, we're approaching the negative 1/2. And what that means is, we're going to have to think of this as the graph of a cubic. And if you don't know, a cubic graph looks something like this, right? Where this point of inflection is. So what we want to do, we want to recreate that point of inflection. So it's going to start approaching it, but it's going to start flattening out. And then it's going to blow up again. And here, it's going to blow up quite a bit because it has to touch this y-intercept of 12. Now, we're going to start coming back down. And it's going to go through the point 1, correct? And then so it goes through 1. And then it's just going to have to start coming back up and go through 4 and shoot off towards infinity. So this is going to go up all the way and pass through the point 4. And it goes through our things. And if you can see, we can count the turning points. 1, 2, 3, and then 4, 5, 6. because that counts as technically 3 turning points because it's an x cubed. And were this to be an x to the 5th, it would be very similar, except it would just be a little steeper. So it would be even more like a little steeper than that, a lot steeper. It'd be like almost like a line or more so. Something like this, like a Tetris piece even. And here is our 3 graphs, and I will say we're done. And thank you guys for watching this video all the way through. I appreciate you sticking with it, and I hope you learned something. Remember, keep on learning, keep on having fun. Thanks for watching.